Hello everyone, welcome back. This is a new lecture in your course Linux for Absolute Beginners by Avionics. My name is Ahmed, and in this section we are discussing file manipulation in Linux, how to work with files. And we have stopped in the previous lecture at how we can copy files from one location to another. Let's see now how we can move a file from one location to another. But before we start, we have to make an important distinction between file moving and file copying. Actually, moving is no more than copying than deleting. So when you are moving a file from one location to another, you are copying this file or directory, then you are deleting the source. That's one. The second thing is that Linux uses the move command, which is mv, to not only move files but also to rename them. Let's think about it. Actually, moving one file from one location to another on the same file system is effectively just renaming it. Let's have a look. Now let's say I want to rename file 1 to be file 3, for example. I will use mv for move file 1, then I'm going to pass in the new name, file 3. So mv here is effectively renaming the file. I'm not moving the file physically because it is on the same file system, so I'm not moving the data physically from one file system to another. I'm just renaming it. So moving file 1 to file 3 is just renaming file 1 to be file 3. It is the same file with the same contents. Let's have a look. This is file 1, but its name is file 3. Same thing holds if I am changing not only the file name but also the file directory, because the directory of the file or the path of the file is part of its name as far as Linux is concerned. So for example, if I have a look at ls file 2, for example, it is called file 2, and the location of this is in /home/ahmed/file 2. This is the file name actually. This whole path is considered to be part of the file name and not only just the file name as file 2. It's /home/ahmed/file 2. That is because I can have a file in /home/documents /ahmed/documents/file 2. Now I have two files with the name file 2, but what distinguishes them from each other is that one of them is in /home/ahmed directly and the other is in /home/ahmed/documents. So this is the file name from the slash till the last character in the path. This is file name. So moving a file from one location to another on the same file system is effectively renaming it. But if I have more than one file system, if I have two disks, for example, and I want to move some files from one disk to another, I'm not only renaming the files, I am physically moving them. I'm moving the data from one location to another, and that, of course, will take time. You can experience with large files on your Linux installation and see for yourself the time difference between moving a file, no matter how huge it was, from one location on the same file system to another, and moving that same huge file from one file system to another totally different file system, let's say on a USB drive or something, or another disk, for example, and you will see for yourself how much extra time it takes to move that file than moving it or renaming it on the same file system. Now let's get back to our move command, and the options that move command offers are the same as cp. So you can use mv-i in order to give you an interactive output. So we have here, let's say, file 2, and if I want to move it to desktop, and as we said, cp and mv are actually the same functionality, except that mv deletes the source file after copying it, while cp just copies the file from the source to the destination. So all the options that hold and all the operations that hold in cp are the same in mv. So mv file 2, and I'm gonna give it a new name at the destination file 1, but file 1 actually exists. Adding -i to the command like this will make mv prompt me the same way cp did, asking me to overwrite file 1. I will say no, and this will abort the whole operation. It will not move the file from the source to the destination. File 2 is still at my current location. And I can use also -f in order to force this move without asking questions or without giving me any prompts. However, mv does not contain -p or -a or -r. This is one important difference between mv and cp. MV can move whole directories from one location to another, so I can move desktops to, for example, /opt, and I can have a totally new name for that directory, or I can leave the destination directory like this, and this will just move the desktop directory with all its contents to the /opt, and it will move it recursively, and it will also retain the permissions and the modification time, so I needn't use -a or -p or -r because they are actually internally used when MV is used, whether with a file or with a directory. Now let's start discussing symbolic links. Symbolic links, although the name might seem referring to something that is difficult, it is not. Actually, it's very simple. Symbolic links are just shortcuts. So for example, if you have a program that is installed in a very deep path on the system, like for example /usr /local /bin /python, for example, /python 2.4, and you want to have a shortcut for this program on your home directory in order to just launch it from the shortcut instead of navigating to that long directory every time you want to launch the program, or every time you want to even access this directory, because a symbolic link may refer to a directory or to a file. So you create a shortcut, and in Linux this is called a link or a symbolic link. The command that is used to do this sort of shortcuts is called ln, short for link, of course, and we have two types of links in Linux. We have hard links and we have soft links. A hard link will duplicate the directory entry for a file, making another reference to it. Now let's have an example. Let's say I want to create a hard link for the file that is called file2 on my current directory. So using ln command, I will type the destination, which is file2. This is my destination file or my subject file, and then I'll type in the name of the link that I want to create. Let's say h-file and h4 hard link. Okay, now I have file2 and I have h-file, which is pointing to file2. But notice here a very important thing. H-file is a file that has a size, as you can see here, and notice here this number. This number has changed to be 2. If you have a look at another file that does not have symbolic links, like file1 for example, you will see that the second column of the metadata is 1, and 1 means that this file does not have any hard links pointing to it. When you create one or more hard links to a file, this number changes incrementally to reflect the number of hard links that are pointing to the file. So that's 2, which is the file itself, plus one hard link. So here I have one hard link pointing to the file. Now let's say I want to add some more text to this file. Let's say I'll add this random text like this, and I'll click save. Now if I have a look at h-file, which is the link, you will see that its size immediately changed to be 1850, which is the same size as file2. They both have the same size. Actually, they are both the same file. Any changes done here in file2 will be reflected to h-file and vice versa. If you get here file2, you see that the text that I've added to h-file is here, it is reflected here, and of course the size, as we have mentioned, is the same. Now, what if I want to delete file2? If I did that, using the rm command, we're going to cover the rm command later in this section, the h-file file is still here, and it is having the same content. I can cat h-file again, and it will give me the same output that I did. This is file2 followed by the random text that I have just added to the file. Okay, and notice here that number changed from 2 to 1. Let's clear the screen and show you this again. h-file. Here the number is 1 instead of 2. This means that there are no more hard links pointing to the file. Now notice here that the file is still holding the same amount of space on the file system. Deleting file2 did not free up the space. The space is still used, and it is still used by one of the links that were pointing to file2, which is 1850. Okay, I will free this space only if I deleted h-file like this. Now I have no files with either file2 or h-file. Now the space is cleared on the file system. Of course, this is a very tiny amount of space, but if you have a file that is several gigabytes in size and you want to delete it in order to free up some space on the file system, having one or more hard links pointing at this file will not free up the space if the file is deleted, you will have to delete each and every hard link pointing to the file in order to free up the space. And those are the differences between hard links and soft links. Soft links, on the other hand, are just a file that is pointing to another file. It does not have the same size. It is not a duplicate directory entry. It is just a point. And in order to create a soft link, you will have to use the -s option. So let's create a soft link for the file that is called file3, for example, and I will create s file, s for soft. Okay. And notice here what happens when I ls -ls file. Here, notice that the size of the file is not the size of file3. File3 has the size of 15, okay, while this has the size of 5. Now, in order to illustrate this more, I will add that amount of text that I copied from lorem ipsum site. Okay, now let's clear the screen, and again, let's ls file3. File3 is 1850 or 1850, while s file, which is a symbolic link, is still 5. It did not reflect the change in the size of the file. Actually, this is just a point. This is just a reference to file3. This is not a file in itself. This is not a file that consumes space in itself. Now, notice what happens if I removed file3. Now, when I want to have a look at S file, I'll see that its color has turned into red. That is because it becomes what's called an orphaned link. It does not have any file to point to. And when I try to have a look at S file again, I will see that it's just an empty file. Notice here the difference between what happened in hard links and soft links. In hard links, when I deleted the original file, the link still had the same information, the same content as the original file, and it was still consuming the same amount of space. But here, when I deleted the file, the original file, the space has been cleared. Now no file is consuming the 1850 bytes. And in addition, when I tried to see the contents of S file, which is the link, I saw nothing, just pointing at a new file because the link is now orphaned. It does not have any file to be pointing to. On the other hand, when I did the same thing with the hard links and when I accessed the H file after the original file has been deleted, I had access to the content. So that is one difference between soft links and hard links. And one last very important difference is that hard links, because of their nature, cannot be created across file systems. So for example here, if I have a file system that is like this one, this is a CD-ROM, I can create a soft link from one of those files on the CD, like /media Ahmed VBox editions, and I can choose any file here like run as root.sh, and I will call this test.sh. Okay, now if I have a look at test.sh, I'll see that it is pointing, using this symbol, it is pointing at this path and this file, run as root.sh. But if I try to make that same thing, let's see this htest.sh, and I omitted -s, if I try to make a hard link, it will fail. ln failed to create a hard link, htest.sh, because I am trying to create a hard link that is pointing at a file that is on a different file system. As you can see here from the error message, invalid cross-device link. Now in the next lecture, we're gonna see how we can delete files, so stay tuned.